Hi all, welcome to lecture number 6 which deals on internal RAM organization of 8051. The internal memory of 8051 where the RAM resides has 8-bit address line and 8-bit data line. So internal memory of 8051 where the RAM resides has address bus equal to 8-bit, data bus equal to 8-bit. So we can visualize the memory like this is the internal memory. This is the data bus which is 8-bit wide. Then we have address bus which is also 8-bit wide, which means that each location can store 8-bit of data or 1 byte of data. Let's see, consider this is a location in the memory. This location can store 8-bit of data 1, 2, 3, 4, 5, 6, 7 and 8. That is the physical meaning of 8 data line. Now, like this, how many locations are available in this memory? For that, we will do the simple calculation 2 raised to number of address lines. 2 raised to number of address lines. That is 2 raised to 8 equal to 256. Therefore, we have 256 location inside this memory and each location can store 8-bit of data. So the memory can be represented as 256 byte into 8. This is a memory representation. If you are not understanding this representation, go watch my memory video. So this is the internal memory of 8051. So what will be the address range of this memory? So address range, for address range, we have 8-bit for each address, right? So the range will be, first of all, I will write in binary. First address will be 8 zeros. 2, it goes from 80 all the way up to 8 ones. So this is the address range. This is the binary representation of the address range. Now, in our program, we will not use this binary representation. We are going for hexadecimal representation. So, for hexadecimal representation, how to convert this binary representation into hexadecimal representation? We will see. I have already explained this in my hexadecimal video. So, from LSB, group 4 bits. So this is the first 4 bit, this is the second 4 bit. Here also do the same thing. From LSB, group first 4 bit, then the second 4 bit. Then write corresponding hexa values for this 4 bit. 0000 is nothing but 0. 0000 is also 0. So this is the corresponding binary representation of this, corresponding hexadecimal representation of this 8-bit number. So this is hexadecimal representation. So 2 for 1111 in hexa we write F, and for this 4-bit also we write F. So this is the range. So this is the address range in hexadecimal representation. Now for your understanding, I will also give decimal representation. So 0 is nothing but 0. 2 FF. You can either convert FF to decimal using a calculator, or we can use the weights. So this is the 8-bit number, right? What are the weights for 8-bit number? 2 raised to 0, 2 raised to 1, 2 raised to 2, all the way up to 2 raised to 7. So here we are using all weights because there is 1 below every weight. So we are taking every weight. So adding up all the weights, that is 2 raised to 7 plus 2 raised to 6 plus 2 raised to 5 plus 2 raised to 4 plus 2 raised to 3 plus 2 raised to 2 plus 2 raised to 1 plus 2 raised to 0, we will get 255. So our range is from 0 to 255. 0 to 255, how many numbers we will get? 256. That's why our memory has 256 location. So this is the address range. So keep this in mind because we are only using hexadecimal representation in our programs. Okay. Also, you should also know how to convert this number to its corresponding binary. So now this is the address range 0 to 255. Now this memory which has address from 00 to FF is again divided into two parts. It is equally divided. This is first 128 locations. This is second 128 locations. And this is our internal RAM of 8051. This is our internal RAM. So that's why in our block diagram explanation I have told you that internal RAM is 128 bytes. Okay, so this is the internal RAM. So what will be the address range? 00 to 7F. 7F when converted to decimal will give 127. So 0 to 127, how many locations we will get? 128 locations. So this is the internal RAM. Then this rest of the locations are given for special function registers. There are 128 locations, but we don't have 128 special function registers. So some locations are given for special function registers. So this is the organization of the RAM. Now we will see how these 128 bytes are divided. Okay, now we will see the organization of first 128 bytes. The first 128 bytes is subdivided into three groups: working registers, bit addressable area, and general purpose area. Working registers is nothing but it is the most commonly used registers when we are programming. So we will see the address range. So this is the starting address. Our address is of 8-bit. I will use hexadecimal representation here. So first address is 00H, right? Now, what is the second address? It is like a decimal only. Next is 01. Now 02, 03, 04, 05, 06, 07. So these are the first 8 location, right? 0 to 7 means 8 location. And this is our bank 0 or register bank 0. This location is addressed by the name R0 in our program. This is register R0. We can either use this address or this name. We are going to use this name in our program. Okay. Now R1, R2, R3, R4, R5, R6 and R7. So these are the 8 general purpose registers in bank 0. Now after 08, what is address? Sorry, 07, what is address? 08, 09. Here, just understand this. In decimal, after 9, we are writing 10, that is 10, right? But here after 9, we will not write 10 because we have how many characters here? 16 characters. So after 9, we have a character A, right? So we will write 0A. Then we have 0B, 0C, 0D, 0E and 0F. Now these are the second 8 locations. This is bank 1. Bank 1. This is our bank 1. This bank also have same set of registers. R0, R1, R2, R3, R4, R5, R6, R7. Okay, this is the bank 1. Now again continuing with our address range. After 0F, so F is the last symbol we have, right? So after 0 in hexadecimal, after 0F only we will write 10. Now it is just like our decimal representation. 10, after 10 we will write 11, 12, 13, 14, 15, 16 and 17. So here is the next 8 locations. This is bank 2. Bank 2 also have same set of registers. The name is same. R0, R1, R2, R3, R4, R5, R6 and R7. 8 registers. So this is our bank 2. Now we have bank 3. After 17 we are writing 18, 19. After 9 we are writing 1A, 1B, 1C, 1D, 1E and 1F. Again 8 location. This is our bank 3. Again same names R0, R1, R2, R3, R4, R5, R6, R7. So these are the 4 register banks in our internal RAM of 8051. I have also shown you how you can write the address in hexadecimal. So how many locations are there? 8 into 4, 32 location. So first 32 location in our RAM are given for working registers, and they are divided into 4 banks. Each bank have 8 registers. Their names are R0 to R7. So now I'm writing an instruction move a comma R0. The 8-bit data in R0 is moved to accumulator by this instruction. But from which R0 the content is moved to accumulator? Is this R0 or this R0, this R0 or this R0? So for specifying which R0, we first want to select banks. Here we have 4 banks, so we have to select a specified bank. For selection, we have 2 bits in PSW, RS1 and RS0. These bits are in PSW or program status word. 2 bits means we will get 4 combinations: 00, 01, 10, 11. This 00 combination will select bank 0, 01 bank 1, 10 bank 2, and 11 bank 3. This is how we select the bank, the required bank. And keep this in mind, on reset, bank 0 is selected as default bank. Now let's see bit addressable area inside our RAM. So continuing with our address, after 1F, the address is 20, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, then 2A, 2B, 2C, 2D, 2E, 2F. So next 16 locations are bit addressable area. To understand bit addressable area, let us consider an example. Let us now consider this entire memory to be a colony, and colony have number of houses in it. So consider each location to be a house, and a house can carry 8 people. So a house can accommodate 8 people. 8 people are nothing but 8 bits. Okay. So here in this area and this area, each house is having an address. This house is having an address 00H. This house is having an address 0EH. So in byte addressable area, that is this area and this area, each house is having an address, but the person inside the house is not having address. Individual address is not provided in this area and this area, but this area is different because here individual address are also provided. That is, this house has an address 20H. Likewise, all houses, 16 houses have an address. Okay. So we can either refer to this house using this address, and we can also refer to each people in that house using their addresses. So we are giving each bit an address. That's why it is called bit addressable area. So how can we give each bit an address? Let's see. So let's now divide this location into 8 parts. So we have 8 parts and each part is given a separate address. So this is given the address 00H. This is given the address 01H. Like this 8-bit address is given 01, then this 02, 03, 04, 05, 06, 07. Then here 08 for this location. For LSB bit of location number 21, we are giving the address 08 and it will come up to 0F. Then for this location 10 to 17, then 18 to 1F. Likewise, it will go up to 78 to 7F. So I am not writing the entire address, I am only writing the end addresses. You can fill the remaining address like this only. So how many bits are here? How many addressable bits are there in this area? Let's see. How many locations are there? 16 locations are there. 1, 2, 3, like 16 locations are there. So number of bits equal to 16 into each location can store 8 bit. So into 8 equal to 128 bits are there in total. That's why the address range is from 00 to 7F. Okay. Then there are specific instruction in the instruction set of 8051 for changing these bits or setting or resetting these bits. I will show two instructions. Like set B is one instruction. Set B means that specific bit will be made 1. So I am giving set B this address. Which address? 0F. 0FH. I am giving this instruction in my program. Then in our RAM, in the bit addressable area, the bit having address 0F will be made 1. So this bit will be, this position will be made 1. Now another instruction is clear. Clear 0F means what? This position will be made 0. Okay. So these kinds of instructions are there in the instruction set. We will look on this instruction in detail when we study instruction set. So this is the bit addressable area. Here each bit can be addressed separately, but here and here only a location can be addressed. That is, a byte can be addressed, not bit can be addressed. So these and these are byte addressable area, and this is the bit addressable area of our RAM. We have 16 locations, and how many bits? 16 into 8, 128 individually addressable bits in this location. And we have specific instruction in the instruction set to set and reset these bits. Now we are going to the third part or third area in the RAM. These are general purpose area. So after 2F, the address will be 30, then 31. Likewise, it will go up to our last address, that is 7F. 7F is nothing but 127. So from 0 to 127, we have total of 128 location in our RAM. This area is also like this, but the change is that this area, each location has a specific name, right? But in this area, there is no specific name for each location. We can address each location using that address. So if we want this location, means you can use this address. So this location can be used by a programmer in his program to store some values. Okay. So now coming to the summary of the internal RAM structure. 8051 have an internal RAM of 128 bytes or 128 location, and a location is given 8-bit address. A location can store 8-bit data. It is divided into 3 parts. First part is working registers. It has 4 bank 0, bank 1, bank 2 and bank 3. Each bank has 8 locations or 8 registers starting from R0 to R7. So 8 into 4, 32 locations are given for working registers. Then the next area is bit addressable area. Here the peculiarity is that here each location have an address. Apart from that, each individual bit can be also addressed. So here we have total of 16 locations. And how many bits are there? 16 into 8, 128 bits are there which can be individually addressed. So total 48 locations are gone. Now the rest 80 location, that is 127, 128 minus 48, that is 80 locations are given for general purpose area. So this is the RAM organization of 8051. I hope you have understood. Please comment below how you feel about this lecture.